let's look at this in terms of a Taylor series. Remember, a Taylor series, f of x equals f of a plus the first derivative, x minus a over 1 factorial. The second derivative at a, x minus a squared over 2 factorial. Is just a specific or a different case where Maclaurin series was at a equals 0. So let's look at, find the Taylor series for f of x equals log x at a equals 2. So basically, f of x log x, and we're going to just start taking derivatives like we did before. So the first derivative is 1 over x, and I'm just going to write it as x to the power of minus 1. Now the second derivative is minus 1x to the minus 2. Third derivative is minus or plus, because minus 2 times minus 1, so plus 1 times 2. And I'm not going to expand it out because then we'll see the pattern a bit quicker. X to the minus 3. The fourth derivative is minus 1 times 2 times 3, x to the power of minus 4. When we bring this down, we're going to get a plus again, so it's going to be plus 1 times 2 times 3 times 4, x to the minus 5. And hopefully you can see that the nth term, if I move this up a bit, the nth term is, or the nth derivative is minus 1 to the power of n plus 1, because the third one or the second one is minus. The third one is plus. So it could just be n, actually. Oh, yeah, n plus 1. And what do we have here? The fifth is 1 times 2 times 3 times 4, so it's n minus 1 factorial, x to the power of n minus 1. Now, if we have, if we look at the derivative at x equals 2, because remember, for the Taylor series, that's what we want. The derivative at x equals 2, the second derivative at x equals 2, the third derivative x equals 2, and then we get this x minus 2 squared. So what we're going to have is at 2, it's log of 2, then it's 1 over 2, then it's minus 1 over 2 squared, then it's 2 factorial over 2 to the power of 3, minus 3 factorial over 2 to the power of 4, 4 factorial over 2 to the power of 5. So the nth term, if you think about it, the nth term is going to be the n minus 1 factorial over 2 to the power of n. And then we just have to figure out, is it going to be minus or negative? Is it going to be minus or negative? So the fourth one is a negative. So it's going to be minus 1 to the power of n. The 4, it is negative, so we have to put a plus 1 in there for that. Okay? And that's the way I do it. Like, so the fourth one, we need a negative, so minus 1 to the power of 4 is going to give us positive, so just put a plus 1. Okay, and it's not the best, but f of n, if I write it again up here, is going to be of 2, remember, is going to equal minus 1 to the power of n plus 1, n minus 1 factorial over 2 to the power of n. Okay? So what does that give us for f of x, which is log x at x equals 2? And here we're going to just fill in the Maclaurin series. Sorry, the Taylor series. So remember again, there's the Taylor series. There's the Taylor series. So we're just going to start filling this in. Okay? At x equals 2. So we get, the first one is f of 2. Then the first derivative at 2, x minus 2 to the power of 1 over 1 factorial, plus the second derivative at 2, x minus 2 squared over 2 factorial, plus the third derivative at 2, x minus 2 to the power of 3 over 3 factorial. Okay, so what we've got to put in is these derivatives or these derivative terms, and then it's all the way up to plus our nth term, which is the nth of 2, x minus 2 to the power of n over n factorial. Okay, So the F2 is going to stay as it is. F2, nothing really happens there. What was this? The first derivative was 1 over 2. So this is going to be plus 1 over 2 x minus 2 over 1 factorial. Plus this is going to be minus. So we might as well put the minus in straight away. Minus 1 over 2 squared over x minus 2 squared over 2 factorial. Sorry, this is 1 over 2 squared, sorry. Not 2 factorial, 1 over 2 squared. Plus, we're after, this is the first, the second, the third. What's the third? It is 2 factorial over 2 to the power of 3 times x minus 2 to the power of 3 over 3 factorial minus 3 factorial over 2 to the power of 4 x minus 2 to the power of 4 over 3 factorial. Sorry, this becomes 4 factorial. And we keep going like that until we get the nth term. And hopefully you can see that some of this is going to cancel out. It's a bit messy there, but some of this is going to cancel out. So here you're going to get 2 factorial over 3 factorial is just going to give us 3. 3 factorial cancels out with 4 factorial just to give us 4. The next one will be 4 factorial on top and 5 factorial on the bottom to give 5. So what we would get if we had our little pattern, our nth term, is going to be f of 2. F of 2 was log 2 plus a half x to the minus 2 minus 1 over 2 squared x to the minus 2 squared over 2 factorial plus 1 over 2 cubed x to the minus 2 cubed over 3 minus 1 over 2 to the power of 4 x minus 2 to the power of 4 over 4 factorial. And we could keep going like that until we see a pattern. That should be log 2, obviously. Now, the log 2 sort of sits out by itself. It's going to be the log of 2 plus the rest we can put into a little pattern. It's going to be a half. And if we go n equals 1 to infinity, this is going to be a half or 1 over 2 to the power of n, x minus 2 to the power of n, because this is the first term, second term, third term. And the other thing, what else have we got here? We've got over n. And I think that's all of it. We've got 1 over 2 to the power of 4, the fourth term, x minus 2 to the power of 4 over 4. Remember, that should be 4 because they cancelled out. Now all we've got to get is the negative in the right spot, minus 1. So the first term is a positive. The second term is a negative. So this must be n plus 1. So the first term, to get the first term to be a positive, here we've got 1 plus 1 is 2. Well, minus 1 squared is plus 1. So that's how we get a positive for that first one. Okay, hopefully that makes sense. Sorry, I bumbled my way through a bit there. Thanks. That was shit.